MVC framework. So you have your front controller, which parses the URL and says, oh, you want to talk to a certain component. And it instantiates a web response handler class. Inside that class, there are a number of methods that, again, based on the URL. So if the URL said something like customer/view, the web response handler would be called something like customer controller, customer action, and there would be a view method inside of it that the controller would invoke and pass the request parameters to, which would then invoke some type of API, make a backend call to a database to retrieve model objects, and the model objects then would be transferred to the view technology. So every framework has some kind of view technology. Java has JSP, Groovy has GSP, PHP has PHTML. There are tons of frameworks. .NET MVC has a whole bunch of other ones. But there's some mechanism by which the controller sends that model data that's going to be presented in the view components to the view, and then ultimately it's rendered by the view technology and sent back to the browser. All right, that's the quick high-level overview of what the architecture is. Now, when we talk about vulnerabilities in web frameworks, okay, they're very similar to what happens in your core code libraries. But we're going to just break them up into data flow and non-data flow vulnerabilities. We're going to cover all these today. And I've got a lot to go through, so I'm going to kind of get through this quickly. But if you have questions, please don't hesitate to stop me and ask, because that makes this a lot more productive discussion. All right?
Are you going to share your slides later?
Yes, they will be sent out. So one of the key things, before we go into any frameworks, remember that frameworks are written in a bunch of languages. Python, C#, Java. And the key thing you want to start with, if you really want to find vulnerabilities, is you got to understand concatenation. Because whenever you're concatenating untrusted data into SQL, into strings that are output into HTML, you're going to have vulnerabilities. So in order to effectively look through source code and find problems, you need to understand all the different mechanisms that concatenation can occur. And this is kind of a beginning list, but I just want to show you that it's very varied and it's very distinctive in terms of how each language does things and does concatenation. All right, so when we talk about finding SQL injection in frameworks, we're talking mainly about object relational mapping frameworks. Hibernate, IBATIS, Active Record, Gorham. Okay, but the thing is, when you're looking through code, you're going to look for methods that are named like query, SQL, execute, where, find, and you're going to look for concatenation. If you find that, you got a problem. SQL injection. All right, command injection. Again, with frameworks, there are many ways that system commands can be executed. And this is just Ruby. All right, these are all the different ways that you can execute commands. And here we're taking untrusted data, assigning it, concatenating it with date, and then passing it to one of these functions that's going to ultimately execute that command, the attacker's command. All right, and so you have to be familiar with, just Google it. All right, so there's other types of command injection with frameworks. So every framework, or most frameworks, have some type of scripting language. And for example, this example up here is .NET MVC's Razor scripting language. Now, if you look at it, this is the safe case where, and what a templating language is where you take variables and you interpolate them in the string where the variable exists and take the values that are in the variables and put them in there. So here, we're saying that question user input is some untrusted data that's coming in, and it's building this eventual string down here. Now, you look at that and you say, well, what could they do? This is building some mail campaign, email to and from, and some body message, and customizing the message, right? Well, every scripting templating language has a way for you to call out and make system calls. So in this particular case with Razor, if you use the @curly brace and embed C# code in there, you can now execute arbitrary system commands on the server that's being attacked. Okay, in this particular case, we're doing something very benign. calling the calc function, but you get the picture. Oh, okay, so I already explained that. So in other frameworks, like Spring MVC and Struts 2, they also have EL, which is expression language, which is a type of templating language as well. And each of the EL is evaluated like a separate language. So in former versions of Struts 2, you could actually execute system commands like exit with this syntax here. Now they fixed that, but all of these scripting languages, and when you look at another framework that utilizes scripting framework or scripting language, you have to be looking for these type of problems. All right, let's talk about parameter tampering. So everybody knows what parameter tampering is. It's where when you pass in something, you can do what? See somebody's what? Information, right? Somebody else's information. So here in this particular case, we got a model object called loanApps, and it has a finder method. And it's passing in, can anyone tell me what it's passing in? A loan ID, but where is it coming from? Request parameter. Okay, what does that mean? If my URL said loan ID 123, what do you think the hacker can do? 2 for whatever, and then see someone else's loan app. So the solution is to kind of narrow down the scope of what is searched on by using a reference outside of it. So current user, look up their loan apps and find the loan ID associated with the current user. That's what that's doing. So it limits the parameter tampering to just the user's loan apps. So they can go try different numbers, it'll bring up nothing, or it could bring up their other loan app. All right, let's talk about open redirects or header injection if the framework doesn't encode. Every single framework has some kind of special way to send the user to a different website. So all of these methods here, if they're receiving untrusted data, are possible attack points for open redirects. Can anyone tell me what the reason why open redirect is bad? What is it used for? So you type a URL and you say bankofamerica.com URL equals www.attacker.com, right? So phishing, right? You make these URLs look like they're valid, but they're really going to an attacker's website. Then we look at path manipulation, okay? Every framework that's listed here has some type of vulnerability where if untrusted data is sent to one of these methods or one of these classes, the attacker can control what files are displayed in the browser. And we're going to have a demo on that, so you're going to actually see that in action. So does everybody kind of see that? All right. Struts 2 is kind of special. They don't have a parameter per se. We're going to actually go over this in the demo, but I want to give you a little intro. The action class public getter and setters of the action class are settable via request parameters. So this is just like in that previous example where we said params and we said some loan ID. This is the same thing. If we had get loan ID, set loan ID, then we could do the same thing in the URL. Just pass in loan ID, and this would get set automatically. Now what we're doing here is we're saying where to send the user when we have a success. When we return success from the execute method, it's going to find this URL. Because the attacker controls it, now it's an open redirect. Okay? All right, so let's go ahead and take a look at what an open redirect can do in struts. All right. So this is okay. So this is a typical struts application that we're looking at here. All right. The way you know it's a struts 2 application is there's a struts.xml file. Can everybody read that? Apologize. But it's struts.xml. Now, if you look here, this right here is the part that kind of what I highlighted in that former PowerPoint. Okay, can people see? Okay, all right, can people read that? Okay, remember how we were talking about this? Oh, sorry. I thought I was doing it. Okay, so here we have a result named test. In our action, if we return the string test, we're going to send the user to the X URL. It's a variable, and we're saying dynamically evaluate X URL. Now, where does X URL come from? Well, if you look over here, we're specifying when a request comes in for /SVR redirect, we want to invoke this web response handler class, SVR redirect action. Okay, and inside of that, because we don't specify a method, this is a little older framework, we're going to call an execute method. So let's take a look at that class. Oops. Okay, so this is what the class looks like. Now notice here, there are public getter and setters for XURL. Thank you. And what does that mean about XURL? It is what? It's a request parameter, right? It can be set via request parameter. Okay? Now, when this class is invoked, this is the method that's invoked. Okay? Execute. Execute is the standard method that's invoked when you specify a class associated with an action. Okay? It's going to look for this class. Remember that configuration file where we saw path, server redirect, and then class equals this class? Well, the way the controller knows which method to call in the class is there's a well-defined method called execute that every one of these class has. And it's going to call this. Now, this does some arbitrary stuff, just system outing stuff, but it returns test. Now, test means go look in your configuration file, which we were looking at before, and find a result called test, which is right here, right? Now, where does this forward to? What do we have here? What kind of vulnerability now? Open redirect, exactly. Because we are allowing the attacker to give us a request parameter XURL and send us there. Okay, so now we have an open redirect. Okay, now let's try it. Okay.
What does the test1.txt do? Can you show what
The test one,
test1.txt?
test one. Oh, okay. Thanks. So that's just, it's an arbitrary dummy file. I just put that in there to try to see what happens when I return. Like if I return success in that method, it'll take me to the web-inf test file and render the file back in the browser. Good question.
So, JavaScript probably can be inserted over there.
Well, this is a URL, so this is not being output in a page. It's just determining a URL that the request is going to forward to. So I don't think it's going to really be accessible. One thing to try is maybe to set that equal to JavaScript : and see if you can get something to pop that way. So what we can do is we can try that. Okay, so this SVR redirect, I wish I could magnify it, but so what's happening is we have SVR redirect, which is pointing to that class, and we also have XURL. Okay, and what we're doing is we're passing now a path which is encoded. So the %2f is a slash, Okay. So what I did was I redirected to the server-side web INF directory. And now I see every single file in the web INF directory. Okay? So these open redirects, they're pretty bad because not only can you see the file, but which file do you want to open up on the server? This is from my browser. Pick one. Or let me expand the thing so everybody can see. Okay, security.xml. So let's take a look at that. So I'm going to go security.xml. You see everything, right? Okay, you want to see something even bad, worse? You know what else you can do? You can download and steal, an insider can steal all your IP. So all of your classes in lib are exposed. So for example, I just happen to know that there's a JSTL jar in my lib directory. Oh, lib. Is it this project? Wait, let's see if this will work. Okay, %2f. Oh, I have 2%2f, sorry. Thanks. Let's see if that works. No? Okay. Yeah. Okay. You know, actually, it's a part of a different example. I don't know why the. Oh, whoa. Oh, okay, thanks. Okay, all right. So let's take this step by step here. Lib. No. Okay, there's a different project. I don't know what's causing this, but there's another demo where I show you the actual working. So let's go back to the slides, and we'll actually show you the IP exfiltration in the next other demo part of this. Okay, which is actually coming up next. All right, so I'm going to kill this. All right, so Spring MVC has a similar type mechanism with the model and view object. Let me make this a little bigger. All right, so and this was found by Dennis Cruz originally. So when you return a model and view, it's the same thing as before with struts. You're going to tell it what view to render. Now, what Dennis had found was that you could put forward : and then say /webinf/ like we did before, and start seeing stuff on the server. Okay, but what happens if the developers get smart and they go, okay, well, we're not going to let you put forward : in front. You know, we're going to block that. All right? So what do you think we can do with this type of structure? So what they do is, if you return a string, then it's going to put a path prefix, embed your string, and a suffix. Now, okay, now that's a good try. .. is going to get you up, but what about this part right here? You're still going to be limited to JSP file. What happens if you want to get any file? Let me start up this, and then we'll experiment together. All right. Okay. So what I have here is a form, and it's kind of, whoops. Oh, okay. All right, it's up. What I have is a form where I'm simulating the fact that a lot of apps will hide the next page they want to go to in a hidden field. Okay? So just to make it easier so we can fuzz this stuff, I made it an input editable field. Okay? But for the forward is that part that's going to be passed to that model and view constructor. Now, you said use ... You're on the right track. Now, I kind of gave it away here. What character do you see there is allowing me to get around the JSP? Semicolon. Do you know why? What is a semicolon in the HTTP protocol? What is it used for in your URL? Well, it's part of the query, but it's a more specific thing. It's a path parameter. So it's like a really obscure part of the HTTP spec, where you can use a semicolon to separate your URL from the path parameters. So let's try this out, and this should work. Okay, so you see that? So what I just did was I am downloading the JSTL jar file in the lib directory, all remotely. So if you have some sensitive IP in your lib directory, and you have one of these vulnerabilities, not only can they look anywhere on the server, they can download any file in your lib directory, in your classes directory. So make sure you're aware of this when you're looking for vulnerabilities. All right? All right, let's go back to the slide. Oh, let me kill this.
Maybe a stupid question. Is that by default open?
I'm sorry?
Stupid question. Is that by default open when you install that framework?
Is
that by default possible when you install that framework?
yes. And it's not a stupid question. It's a very intelligent question. The thing is, if it's used incorrectly, then yes, by default they can do this. So you don't have to use that forward that Dennis was talking about. You can also use ... and get around it. Now, this is a third question. So if they're building a URL, let's see here. If they're building a URL, okay, so let's say they're building a URL like this. Okay, they have a http://www.yourserver.com/xyz. No, that's what I can say. Web app /servlet question mark name equals % equal untrusted data. Okay, now, you think they can use this if they oh, sorry. Too big, sorry. Woo! All right. Can you guys, all right. So you see how this URL is, right? Let's say they pass something like this. Well, it wouldn't even be that whole thing, but it would be something similar to, you know, something like this, or web INF. Okay, so let's say they're trying the same attack. Okay, web INF /lib/ your company's jar .jar. Okay, wait, is that right? Yeah. Okay. So let's say that the only part you could sorry, I'm doing this on the fly because I'm trying to add this in. I just thought about it. Okay, if they can only control this part, do you think they can get your jar file? If they can only control that untrusted part, do you think they can do the ... attack? And how? Okay, so in most cases, they can't. But Tomcat, if you're using an older version, had this problem where they parsed the slashes first before the parameters. So you could put in something like x /... and that would get there /... or whatever, and then web INF. And what it would do is it would treat the ... and remove this part right here. You see? And then even in a parameter, you could use the same attack. Because they parse the slashes first. All right? Okay. All right, so this is just discussing the solution, or not the solution, the way that attackers get around the tacking on of the suffix. All right, everybody understand that? Okay, good. All right, so the next thing you need to understand when you're dealing with frameworks is when you're dealing with XSS in particular, you got to know which tags encode, which tags don't encode, and how people can turn off the default encoding. Okay, so this particular case up here is an example of the tags that don't encode. So if you see developers taking untrusted data and using these tags to output them in HTML, you got a, what kind of vulnerability? XSS. All right? Now, this is a way that sometimes developers get themselves into trouble. They disable the default encoding of the tag. So again, when you're looking at the code, if sometimes, we think, oh, they're using this tag by default, it encodes, we're okay. But no, if they turn it off, you got your problem again. This is how every single one of these frameworks can turn off that stopgap. And then we have the code that the beans and tags that do encoding. And notice there's not much difference except for, remember, the flag C out, escape equals false, and C out. So by default, a lot of these tags do encoding. They do HTML encoding, to be specific. And HTML encoding doesn't solve all of the cross-site scripting problems. And I'm not going to go into detail because that's probably a different talk. But that's there for your reference. All right, mass assignment. Does anyone know what mass assignment is? Okay, great. So can anyone describe in a simple set of terms, what mass assignment is, kind of? Okay, all right. Let me give you a little history. It's all right, yeah. So let me give you a little history on how mass assignment came about, all right? So back in the day when we were first making web applications, a lot of the times we were getting request parameters by making these calls, like request.getParameter such and such, request.getParameter such and such, we had tons of these throughout the code when we had these big forms. And then frameworks came about, Struts 1 came about, and kind of said, okay, maybe all that logic and stuff, all that requiring, writing of getting these values, maybe that's not really needed. What we really need is something that ease the developer's life. So what we're going to do is we're going to take any objects that we designate as request-bound objects. So in Struts 1, action form is a request-bound object. Now what that means is there's some magic that's going to happen, right? They're going to look at the request parameter names, and they're going to look in these request-bound objects, and they're going to say, do they have public getter and setters that match the name of the request parameter? If so, hey, map that value into that object automatically. Don't do anything, and just do it. All right? Now, what happened was we went from request params to action form, and then at the time, developers were saying, okay, we have to separate all of our layers. We have to have a view layer, and it's got to be totally separate from our middle tier layer, and we have to have a back-end layer. It's got to all be separate because we might switch this out in the future, and we might switch the view technology out in the future. So we had an action form. Then we had another object called a data transfer or data isolation object, which had almost the exact same fields and attributes as the action form. And we'd map those values over, and then we'd pass this object to the middle tier so that it was that action form didn't pollute our middle tier layer. And then we took that data isolation object that had the exact same fields on the action form, and we took it to the model object. So our model object, who knows what a model object is? Can anyone tell me what a model object is? Like, can you give me some examples?
Yes, so in MVC or not in MVC, we use define views directly to form posts.
Right, so model objects are your customer, your order, your order line, your profile, these objects that represent these database tables, right? So your model objects then also look like your action form as well. You know, like if your action form was on customer view, well, all the fields inside the view were basically the same as model. Now, what did people do? They had these 3 classes for every single object, model object in their class hierarchy. What do you think they did? They put them all together into one class, right? They said, you know what? We don't like all this maintenance. We don't like having 3 of these things. Every time I go to that form and I change it and add one field, I got to go to this other object and I got to go to this other object. Screw that. I'm just going to make my model object request bound, right? Now, what did I say your model object was? It was a representation of your database table, right? And what kind of magic happens now with the model object? Any request parameter can bind any field on that model object, right? So you've kind of lost control now, right? Before, your action form had the limited subset. So this model object might have 10 fields in it because there are 10 columns in the database associated with that object. But the action form mirrored the HTML form. And the HTML form might only have 6 editable fields. But now, you've got this model object that's your magically bound object. And any of those fields can be set, right? Now, but it gets worse. So let's take a look at an example. So Dennis, again, a great researcher that he is, found that you could do this on one object. But what I found is not only can you do it on one object, but you can do it on all its relations. So back when Dennis was doing his research, ORM frameworks were kind of in their infancy. Today, you can have ORM frameworks that have, one-to-many relationship with other objects, many-to-many, reverse relationships. All that stuff is in your model. So here we're saying, for example, customer has a relation to the profile object through one of these relations. Okay? Now, what does that mean? If customer is an auto-magically bound object, what do you think the attacker can do now? He can start setting up fields here. And we're going to take a look at that. I got a demo. All right. So I think it'd be better just to go through the demo because you'll see it better. All right. So let's first take a look at the objects that are going to be problematic. All right. So we have our person object. All right. And this person object, I hope you guys can read that. I'm sorry. Can everybody see that? So this person object only has 4 fields, okay? But it's got a relation to a what? A user, right? Now, if you look at the user model object, it's got a bunch of fields, right? Let me make this bigger because. So, what do you think about that? Now, the page that we're going to be updating is just that person object. But since it's got a relation to this table, or this model object now becomes updatable from the person update page. Okay? All right? Now, let's take a look at some of the page forms that I created to try to mimic this. Okay? So the person form has 2 fields that are going to be displayed. Okay? Can you read that? So these 2 fields are the fields that the user thinks they're only allowed to change. Okay? So in that person object, we had, and these fields are first name and last name, right? But now what I did was to simulate what an attacker can do to your apps. So you see that relation? What we did is we said person dot relation dot field on the relation object. And now we can set arbitrary values in the related object, even though we're updating only the person object through mass assignment. All right? So let's let's see how it's done. So, let's see if it started. Okay, it's starting up. Oops, what's going on? Oh, did I shut down the other thing? Did I forget to shut down? Okay, maybe it's.
I'm sure there's not another thing that is running this address.
Yeah, I think I'm running. Let me see here. Okay, sorry. I forgot to kill this. All right, I will kill it. Okay. So is everybody following while this is starting up? Everybody find this kind of somewhat interesting, or it's not like totally boring? Okay. All right. All right, let's see here. All right, come on, start up for me. All right. All right, come on. Okay, let's see here. Oh, crap. Oh, all right. Thank you. Ooh, these fonts are too big now. All right, so what we're going to do is we're going to view people. Okay, that's the person object. All right, and you see how here, this is a sample app called AppViews, and by a great guy, Matt Rabel, created this stuff. He's really great. Now, what we're going to do is, if you look at the source of this page, what you're going to see is, okay, let me see, will this work? Oh no, come on. Shoot. Okay, so I know it's kind of tiny there, but what's here in the page is you have your two input fields, and then you have a bunch of hidden fields, right? Which are what typically an attacker is going to put in using a proxy, all right? And if you want to see what those fields look like, this is basically the output that's generated, all right? Now, what we're going to do is we're going to update the table person. So you can see I changed the person table, but then I'm going to show you that another table gets updated in this process as well. So here, let's take a look at the data. Let me refresh this. All right, so here, notice this is the person table. We have Matt Rabel and this other person. And then in the app user table, we only have 2 rows. Okay? 2 rows. So this is the user associated with the person. All right, now, if we save this, we get a message. Oh, we saved the person successfully. All right, great. Now, let's check out the database. And what happened? All right, so person now, we've updated the name from the first name and last name in the form to test, right? But what about the other table, the relation table? Oh, we just added a new row. And we not only did we add a new row, but we changed this new row, its password to XXS, or I mean, whatever we wanted, right? So we've added a new row. And this goes on and on and on through all the relations in your application. So think about this. If you were updating an order table, and an order is related to a customer, and a customer is related to a profile, and inside that profile you have your password and any other things, an attacker might be able to actually traverse all those pathways and update someone else's password, someone else's profile ID. They can set the profile ID equal to some number and set it to a password. Like most of your admin accounts are ID 0 or 1. All right? So this is bad stuff. And we got to address it. All right, so let's go back to the slides. So everybody understands mass assignment, right? Great. Did my job. Now, this is how you identify, oops, sorry. This is how you identify mass assignment across all of these frameworks. Now, believe it or not, every single one of these frameworks has it. And if there's some kind of magic binding from request parameters to your model objects in your framework, even though it's not up here, I can almost guarantee you got the same problem. All right, so talking about mitigations of mass assignment, you can specify that certain fields are not auto-magically bindable. Okay, you can use whitelists, you can use blacklists. It's preferable to use whitelists. Every one of these frameworks has something, except some of the frameworks don't. So you're kind of stuck implementing your own solution. Yes?
Are there any frameworks that are better than the other in the case that by default they exclude the relationship object or something like that?
If you're talking about the relation object, I don't think so. But I've only done testing with the Java-based frameworks. So I haven't done, if Neil was in here, I'd ask him. Yes?
Would you recommend one over the other, let's say using the bind include or bind excludes on the data model, or would you recommend using that data protection object, or does it matter, either one's?
You know, I think either one, if you do them well, they will work in the same way. Good question. I'm sorry? Yeah, that's a good idea. No, that's good too. Use whitelists and blacklists. All right, when we talk about file upload with web frameworks, okay, one of the problems that I see a lot is that each of these web frameworks handles additional executable file types. Now, when I say executable file types, like in Java, everybody knows JSPs, right? But very few people actually probably work with JSPFs and JSPX. And in .NET MVC, there's actually VB.HTML, CSHTML, ASP, ASPX, ASCX. And in PHP, you have .php file, .include file, .phtml files. And the reason why these are important is that when people limit their file uploads, they sometimes say, well, I'm going to exclude certain extensions. They forget about these. And the problem is that when you combine certain low-risk vulnerabilities together, they become a super massively big risk item, which I'm going to show you at the end of this, in the end demo, where we can create a remote command shell on an application. All right, so for cross-site request forgery, a lot of the frameworks have some type of solution for cross-site request forgery. This is just the listing of it. Some of them do, some of them don't. If you can use them out of the box, it's the best way to protect yourself against it. Okay, authorization and authentication bypasses. So every web framework is going to have some type of request filtering mechanism. So they're going to, for every request, they're going to run some logic before the request and give you opportunities to run some logic after. That's the place where you want to look for authorization type problems in the source code. Okay? And then there's other things like dev mode. When developers don't have the security infrastructure set up, and they just put these little backdoors in, and then they forget to take them out when it goes to production. All right, race conditions. Anyone know what a race condition is? So has anyone seen a race condition in the real world? Servlet, right, servlet. They're single-threaded, right? So what can happen in a race condition? That's bad.
One thing or the other.
Right, one thing or the other. Yes, thank you. But so let's take a look at an example. So when I say certain frameworks are singletons, okay, like struts 1. So remember this diagram here. Remember this thing? Okay, so when I say that they're singletons, this component specifically is a singleton. Okay, so what happens is two users come in on the same URL, but they have different ID values. They hit the response handler. So they're both going to the view customer. The URL says customer/view, and both of them hit the server at the exact same time, because this is a singleton, there's only one of these customer controllers instantiated, and they both go to the view method inside them. Now, what do you think would cause a problem? What kind of problem do you think you could foresee happening there?
There's like a public property on there. The first one that hits it gets set up.
Right, so the first one that hits it sets some kind of thing to say it's my view, I want to see, my data. The other person comes in, and right before it gets to the execution of all the other code, it gets preempted, and the other guy comes in and says, no, 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 I want you to set it to my view, right? And then they both stop, and the other thread gets to go. Now the first guy goes and he looks at his page and he's saying, what? Whose information is this, right? So this is an example of what you don't want to see. When I say that some framework has components that are singletons, you don't want to see, like when I said action is a singleton, you don't want to see instance variables that are going to be user specific, right? Because then when that code gets executed, it's going to pull that and say, oh, you're user ABC. Yeah. And BCD is actually the one who's looking at it, right? Okay. All right, we have exposed objects. And there are three ways that frameworks expose objects. Okay, one is by convention. So remember when I was talking about the web response handlers? Any public method inside that class is invocable via a request parameter. Okay. So for example, in this particular example here, you don't want to see in your classes privileged and unprivileged methods mixed together. Because an attacker, if they know the privileged method to call, can call it, right? Unless you got some kind of mechanism to protect against it. And there are other things that other frameworks do to try to help you out, but actually cause more problems. So Struts2 has this magical exclamation point, which when you call an action, you can tell it, call some other method, but within the context of execute. So if execute is unprotected, but you've got a protected admin method, they can use this to call your admin method and bypass all of your authorization. Because the framework thinks you're just calling execute. Yeah, I know. The other thing is they have frameworks that will basically export objects for you, make them into SOAP objects, make them into XML RPC objects, make them into HTTP invocable objects. So each of these frameworks have different ways of doing that, and you need to be aware of that so you know what your risk is. I'm trying to run through this. So in insecure configuration, there's a lot of these frameworks that by default will log passwords, log other sensitive information. You've got to turn that off, okay? And then a lot of the frameworks by default will leak information in the error pages or in other locations, in the comments of the code. And this is an example of something that was taken from a book where they were showing you how to do an error page. And can anyone tell me what vulnerability is here? Cross-site scripting, very good. Yeah, XSS, all right. Okay, architectural flaws. You know, I want to get to so I was going to talk about request binding. I got 5 minutes here. What I want to do is get to the big problem where two vulnerabilities are. Okay, so this is just basically saying that frameworks are dependent on other frameworks. So you need to look at the other frameworks that it's using and find those vulnerabilities, because if a framework is dependent on another framework and that framework has a vulnerability, most likely that means the framework you're using has a vulnerability as well. Okay? And then we have inter-framework actions. So struts, the actions are in Struts2, instead of being singletons, they're now multi-threaded. So there's a new instance created per call. But the thing is, when you add Spring to it, can anyone tell me what this does? What kind of bean is this? Somebody said it. It's a singleton. Right. So what does that mean? You've made Struts2 now have the same race condition that Struts1 has by introducing Spring. Because by default, this turns it into a singleton. So any instance variables in that class are going to be problematic. So the way you solve that is make it prototype so it instantiates a new bean every single time. All right, combined thread. This is the big demo, so I got to give this to you guys before you go. I apologize. All right, so Billy Rios talked about client-side blended threats. And the same thing goes for server-side vulnerabilities. You can take two different vulnerabilities and mash them together, and then you got a remote command shell. So what we're looking at are file disclosure and file upload, okay, with a missed extension. So let's go ahead and do this demo. Oops, darn it, okay. All right, so this demo is right over. Okay, it's going. All right. So the first step is uploading something, okay? So if we go back here and we go to this app, oops, come on. All right, so if we go to the main page, you can upload a file, all right? Now, the file I'm going to upload is called exploit, and what I'm going to upload is a file extension that the developers weren't counting on, which is a JSPF. Okay, and so I'm going to upload this file, and then what I'm going to do is, remember that file directory vulnerability that we had? Okay, so what we can do is we can use this to kind of look around, and lo and behold, what's this folder over here? Uploads. I wonder what's in uploads. All right, well let's take a look. Uploads / oh, my file I uploaded. Now what does that mean? When we do the file disclosure, we're pointing to any file on the server. And guess what? That file, if it's an executable file type, gets what? Executed, right? So here we're going to go ahead and try to run the cmd shell.jspf. Oh, it looks like it's working. All right, let's run a command here. Let's do a nice one because this is my computer. ls-la, and we have a remote shell on the server. So we just combined two of those vulnerabilities, and now we've got a gargantuan problem in our app. Okay, so I know I'm running over. I think that's pretty much what I wanted to cover. I appreciate everybody staying here, and I wish you guys the best the rest of the conference. Thank you very much.